Okay. Because there's a leak somewhere in the circuit. He's making a good seal, but there's a leak somewhere in the circuit. So what do you need to do? Tighten your adjustments. Everything. It could be over here too. The leak could be on the nebulizer area. You didn't thread it in properly. Okay. Alright. A sticking breathing valve is the breathing valve is over here. That green area. For this one, it's inside. You can't see it. So if you check the leak on the patient, you check the leak on the circuit, and it's still not cycling off, probably should just change the circuit. Okay. That's how you troubleshoot. You go from one thing to another that causes it. And if everything's checked off, it's probably the circuit that's wrong. Prolonged inspiration. Again, leaks, really long. Flow rate is too low. Okay, deep breath. Bryce. Flow rate, I mean, Austin, sorry. I saw Bryce. Deep breath. Is that 1 second? You can hear it. Oh, good breath. Long inspiration. What do you think the IE is here? 5. He's exhaling. It's probably 5 to 1 inverse. Yeah? That's not good. So you have to increase it so that it goes faster. So that the I time takes longer. Okay? Or if the pressure is too high, this is properly set, but this is like blow your lungs up. Okay, take a deep breath. Go ahead, put it in. Really long still. So this is set properly, but it's taking a while for it to hit that pressure because it's so high. Remember, it only stops when it hits the pressure. If that pressure is so high, it will keep going until the lungs are really bloated and filled up before it hits the pressure and it stops. So it's one or the other. Okay. No mist from the neb, obviously. Is it hooked up? If not, is there adequate solution in here? Because if there's, remember there's dead volume. We talked about dead volume. Whatever is left in there that does not get nebulized. So you might see something in there, but it doesn't get nebulized and nothing is coming off already then. You know, it's probably done. Or you didn't thread this in properly. That's always an issue, is it's not threaded in properly, and so when the patient takes a breath, it gets, if the patient's holding this and their sweat, hands all of a sudden wet, it means that you needed to thread it in and it was leaking out and the drug just got wasted. Okay, so make sure that this is set properly. And that's it for those 2 slides for troubleshooting. So what you could do is, if you're, here early in the morning, you play with it. We have test lungs here, or you get your own thing. You can take off your own filter. Steve, show you how to use this? Mm-hmm. Yeah. Okay. You put it on the exhalation side. And let's see how much volume we're getting. 1, 2. What's the pressure, Jess? 3, 4,
15,
5, 6, 7, 8. Takes about 8 breaths. It's about 600. Yeah, 600 cc's tidal volume. Okay. So, what else did you notice about the breath? The I time.
short.
Short. It's less than 1 second. So, what do you want to do? What are you going to do if you want to get 800? Increase the I time. Decrease the flow. Decrease the flow.
Decrease the flow.
What affects the tidal volume? increase the pressure. You need to increase the pressure. So what do? You increase the pressure. Okay, this is a fake one, so I'll just go up here. Okay, and then you do it again. 2, 3, 4, 5, 6, 7. Oh, this actually works. 8. I think there's a leak in the bag. 9, 10. That's wrong. 11. It should be going up. 12. That's like 400. Okay, go up on the pressure again. There we go. So what happened to your eye time when you went up on the pressure? It increases, right? So you don't increase your flow to get more volume. You increase your pressure, because as you increase your pressure, your eye time should also extend, right? Because it takes longer to hit that pressure. 2. Does it sound about 1 second? 3. 4. That's about 1 second. 5. 6. 6 to 7. So that's about 686 to 800. At what pressure was that, Jess? Did you notice?
No, I didn't. Oh wow. It's like 20. Yeah, 30.
30? Okay, about 30. But you can see this simulates, there's 3 rubber bands in here. That's a very restricted lung, like someone who has pneumonia, who has atelectasis. It takes that much pressure to get on 800. Whereas with Austin earlier, it only took 10 to 15 to get a huge tidal volume because his lungs are compliant. Okay. So if it has to do with tidal volume, you touch the pressure first. If it has to do with, if the tidal volume was 800 earlier, but the eye time was too short, then you would adjust the flow. Okay? Now sensitivity, he already demonstrated that earlier. All right, a lot of information on IPPB, but this was the kind of like the start of mechanical ventilation. Now you can imagine how it is next semester with actual mechanical ventilation course. So when you talk about positive pressure ventilation next semester, this is a positive pressure ventilator. It's the first very simple one. If you can get how this works, it's easier for you to understand how to work with those high-tech machines back there. Okay, if you have any questions, let me know.